Alright, so in this video, I'm going to solve the equation the eighth root of negative a is equal to 4. So I want to find the value of a. So to solve an equation like this, what I'm going to do is first rewrite the eighth root of negative a as negative a to the power of 1 over a. Because if I have the nth root of a number x, this is the same thing as x to the power of 1 over n. Now, I'm going to let 1 over a equal to negative x. Meaning, a is equal to negative 1 over x if I rearrange these variables, and negative a is equal to 1 over x. So this means that I have 1 over x to the power of negative x is equal to 4. And 1 over x is the same thing as x to the power of negative 1, because any number to the power of negative 1 is 1 over that same number. So now I have x to the power of negative 1 to the power of negative x is equal to 4. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So these two multiply, and I get x to the power of positive x is equal to 4. So this is basically asking what number to the power of that same number is equal to 4. And 4 is the same thing as 2 squared, meaning x is equal to 2. However, we aren't done yet because remember, we're trying to find the value of a, not x. And we let 1 over a equal to negative x. So if 1 over a is equal to negative 2, then this means that a is equal to negative 1/2. Now, before you leave, I actually have another solution to this equation. And to use this to actually solve for the solution, I'm going to be using logarithms. So for the second method, I am going to be using logarithms. So our equation was again a to the power of the eighth root of negative a is equal to 4. And what I'm going to start off by doing is again rewriting this as negative a to the power of 1 over a is equal to 4. But this time, I'm going to take the power of a on both sides. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning these two multiply and cancel out. So I get negative a is equal to 4 to the power of a. Now from here, I'm going to multiply both sides by 4 to the power of negative a. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, I have negative a times 4 to the power of negative a is equal to 4 to the power of a plus negative a, which is 0. And any number to the power of 0 is 1. So I get negative a times 4 to the power of negative a is equal to 1. So this is where logarithms come in. I'm going to rewrite 4 to the power of negative a as e to the power of So I'm going to rewrite 4 to the power of negative a as e to the power of ln of 4 to the power of negative a. And the reason I'm doing this is because the e and ln cancel out and automatically bring 4 to the power of negative a. So this is just the same thing as 4 to the power of negative a. E to the power of the ln of, let's say, 8 is just equal to 8. So they just cancel out. And this is all equal to 1. Now from here, I can move the 4, or sorry, I can move the ln of 4 to the front, this is a property of logarithms. So I get negative a times ln of 4 times e to the power of negative a of ln 4 is equal to 1 times ln 4, because I'm multiplying both sides by ln 4. And this turns into negative a times ln 4 times e to the power of negative a of ln 4 is equal to, I'm going to write ln 4 as ln 2 times e to the power of ln 2, which is just ln 2 times 2, because e to the power of ln of 2 is 2. Now, finally, I'm going to use the W-Lambert function, which states that if I have the W of something in the form a times e to the power of a, this is equal to a. So in this case, I'm going to take the W on both sides. So I get W of negative a times ln 4 times e to the power of negative a of ln 4 is equal to the W of ln 2 times e to the power of ln 2. And now, notice how this is in the form a times e to the power of a. A in this case being negative a times ln 4. So I have negative a times ln 4 times e to the power of negative a times ln 4. So this is all just equal to a, meaning this is equal to negative a times ln 4, which is equal to, again, a times e to the power of ln a, and a in this case is ln 2. So I get negative a times ln 4 is equal to ln 2. And now I'm going to divide both sides by ln 4. So I get negative a is equal to ln of 2 over ln 4, which is the same thing as ln 2 squared. And now I can move the 2 to the front. So I get ln 2 over 2 times ln 2. And these two cancel out. So I get negative a is equal to negative 1/2, or sorry, positive 1/2. And finally, if I multiply both sides by negative 1, I get a is equal to negative 1/2. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 25 to the power of x minus 15 to the power of x is equal to 9 to the power of x. Now what I'm first going to do is I'm going to divide 9 to the power of x on both sides. So now we get 25 to the power of x over 9 over 9 to the power of x minus 15 to the power of x over 9 to the power of x, and this is equal to 9 to the power of x divided by 9 to the power of x is simply 1. Now, 25 to the power of x over 9 to the power of x, this is the same thing as 25 over 9 to the power of x. And same thing with 15 over 9. This is the same thing as 15 over 9 to the power of x. So now this is equal to 1. Now 25 over 9, well 25 is the same thing as 5 squared, and 9 is the same thing as 3 squared. So we could rewrite 25 over 9 as 5 over 3 squared. And this is to the power of x minus, now 15 over 9, this could just simply be simplified to 5 over 3. So 5 over 3 to the power of x. Now I'm going to let x equal 5 over 3 to the power of x. I get x squared minus x minus 1 is equal to 0. This means that x is equal to 1 plus the square root of 5 over 2. So now if we plug this in, we get 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. Now I'm going to take the ln of both sides. So now, because I took the ln, I can actually move this x to the front. So now we have x ln to the power of 5 over 3 equals ln of 1 plus the square root of 5 over 2. And now this can be written as x is equal to, well, for ln, we could actually write this, our ln 1 plus the square root of 5 over 2. We could write this as ln 1 plus the square root of 5 minus 2, minus ln 2. Because when you're subtracting to natural logs or even to normal logarithms, you simply just divide them. So this is the same thing as this. And now this is going to be over. Now the same thing for this. ln 5 minus ln 3. So this is our answer.